Let's attempt to solve the practice problem 1.1, and the problem is calculate the molecular masses of sulfur dioxide and caffeine. We will attempt the first part first, and in order to attempt this question we will first need the mass numbers of sulfur and that of oxygen. As you can see, the mass number of sulfur is 32 while that of oxygen is 16. Now all we have to do is to multiply the mass number of sulfur, which is 32, with 1, because there is only one atom of sulfur in sulfur dioxide molecule. Similarly, we will add this to the mass number of oxygen multiplied by 2, because here the sulfur dioxide molecule contains 2 oxygen atoms. The mass number of one oxygen atom is 16 and there are 2 oxygen atoms, so we will multiply 16 with 2, and after the calculation the molecular mass of sulfur dioxide comes out to be 64 AMU. Now let's go to the second part of the question, which is the molecular mass calculation of caffeine. In order to solve this question, we will need mass numbers of carbon, hydrogen, nitrogen and oxygen. As you can see on the screen that the mass number of carbon is 12, of that of hydrogen is 1, nitrogen mass number is 14 and oxygen is 16. Now all we have to do is to multiply the number of atoms with their mass numbers and finally add all of the masses of the elements in the molecule of caffeine. So here we multiplied the mass of carbon, which is 12, with 8, because there are 8 atoms of carbon in one molecule of caffeine. Similarly, the mass number of hydrogen, which is 1, is multiplied with 10, because there are 10 molecules of hydrogen in one molecule of 10 atoms of hydrogen in one molecule of caffeine. Similarly, the mass number of nitrogen, which is 14, is multiplied with 4, because there are 4 nitrogen atoms in one molecule of caffeine. And the same goes for the oxygen. There are 2 oxygen atoms, so its mass number, which is 16, is multiplied with 2. After doing the calculation, the molecular mass of caffeine comes out to be 194 AMU. Now there is a B part in this question, which said that calculate the number of moles in 5.68 gram of iron. We are going to solve this practice problem as well. First of all, we will extract the data from the question. We are given mass of iron, which is 5.6 gram. Now what we need to find the numbers of moles of iron. So in order to find the numbers of moles of iron, we first need the molar mass of iron, which is mass number of iron, which is 55.85. Now the formula that we will be using has already been discussed with you, and that is number of moles mass in gram, which is given to us 5.6 divided by molar mass. After putting the values in the formula and doing the calculation, the number of moles of iron in 5.68 gram is equal to 0.101 mole. Thank you very much for watching this video patiently. If you like the video and if you are enjoying learning chemistry, please share the video with your friends. Thank you very much.